PHASE stands for Physical Audio Spatialization Engine. It's a framework that Apple unveiled back in June 2021, claiming it will allow us to create complex, interactive, and immersive audio scenes for our apps and games. Now, what does that even mean? Basically, you can construct an audio scene by adding nodes to this graph. And as we know from previous videos, the graph structure can be pretty powerful, allowing us to create complex audio environments to recreate almost any sound we want. The difference here is the user can actually interact with the environment using the audio channels they have available to them to recreate an immersive sound experience. First things first, let's create a new Xcode project, and we'll create a multi-platform app. We can give a name to the project, and then for storage, we won't worry about it today. Next, click Create. Okay, so now we have our content view, and if we go into that, we can import the PHASE framework. Next, if we jump to definition, we can see all the things that are part of this framework. So let's create a class that spatializes the audio, call it AudioSpatializer, and it will inherit from observable object. I'll explain later. Next, we're going to create an engine, and this engine will be a PHASE engine. Now, to learn more about this engine, we can go ahead and click on the definition of it. But first, let's select an update mode. So automatic is what we want to use today because it will make things easier for us. So if we want to learn more about this engine, after we create our init method, we can go ahead and click on jump to definition. So here we could see that this engine is no different than ones we've worked with in the past. It has a start method, a pause method, and a stop method. And the start is always a throw method because we don't know if it's going to work. Next, I'm going to download a sound that I can play through this spatializer. I'm going to be using a website called Looperman, so I'll go ahead and look for a drum loop that sounds really cool. I really like this one. Next, I'll click download and then click download again to download the drum loop. And finally, we'll drag this inside the project and then copy it into the app bundle. Now that we have this inside the project, we can use it as a sound asset, which is what PHASE relies on. So when you load that asset, we have to define it. So first, let's look inside the PHASESoundAsset definition. We can see here that an asset is almost like an audio file. It has a URL and then an asset type. So let's learn more about this asset type. We could see that the asset can either be streamed or loaded directly into memory, i.e. resident or streamed. Actually, the reverse, so flip the two. So we're going to be using resident because that will load it into memory so we don't have to worry about streaming it. And before we do that, let's create the bundle URL. So we'll find our file in the app bundle. And since it's a WAV file, we'll use the extension WAV. And then that exclamation mark at the end there means we're force unwrapping it, so we know that file exists. So if we go into our PHASEAsset definition again, we could see that there is a method for registering a PHASEAsset. So there's a PHASEAssetRegistry, and this is where we actually declare that we're registering this audio file as an asset. But if we go back to our engine thing, we can also see that there's a PHASEAsset registry associated with this engine. So we can actually call that method from our engine. And what this will do is we can load our URL, give it an identifier, and then give it the asset type, a channel layout, and a normalization mode. Each of these will determine how our asset behaves inside the engine, and how we can get back to it later using the identifier. Once we go back to the content view, we can learn more about this normalization mode. Just as the update method, we can also do normalization manually. But let's go ahead and save some time today and do dynamic normalization. In other words, we're going to let Phase worry about it. So let's go ahead and find the asset registry on our engine, and then we're going to go ahead and register the sound asset. So we give it the drum URL, then we can give it any identifier as long as we remember it. I'll give it drum loop, and then the asset type, which is going to be resident, and the channel layout. Now for the channel layout, we can go ahead and see what's inside that definition. And we see that we can init this with an AudioChannelLayoutTag, which basically tells the framework how the audio channels are set up within the file. You can see that if we go into this definition, there's a bunch of surround sound formats that look really cool. But we also do have our classic stereo and mono formats if we scroll down further. So since we're going to be using headphones today, we'll do stereo headphones, and we can verify that this file is stereo by opening up Audacity. And we do in fact see 2 channels along with stereo. So let's go ahead and create that channel layout tag, and we'll do K audio channel layout stereo headphones. Next, we can specify our normalization mode, and since this also does throw, we need to force try it. In other words, our app will crash if this doesn't work. Okay, great. Now let's introduce the next node that's going to be important, the PHASEMixer. This will allow us to mix our sounds to match the environment. You'll notice if you go into the PHASEMixer definition, there's different types of mixers that will help us achieve our goals. First, there's the phase channel mixer definition, which is a generic mixer that applies no environmental effects and no spatialization. Then we have the phase ambient mixer definition. This does apply spatialization effects using math, but without environmental effects. And last but not least, we have the phase spatial mixer definition. This applies both spatialization and environmental effects to the mix. You may have noticed that our phase channel mixer takes an input, which is the spatial pipeline. Now, the spatial pipeline is going to be how it creates or recreates the sound in the environment. And that's going to take some flags that are going to describe how this sound is recreated. And those flags will create entries for each corresponding spatial pipeline in the system. So in a room in real life, think about a cathedral. First, you get the early reflections off the ceiling, and those go directly back to you, kind of like when you're in a gym, actually. I'd say that's more like a gym. But if you're in a cathedral, you're also going to get a lot of late reflections. And that's why it's so good for choirs. It's so great for music that you would hear in a cathedral. So here, if we go into the flags, we can actually see that there's direct path transmission. So that's going to take a direct path to the listener from the sound source. Then there's the early reflections, and then there's the late reverb. And we initialize all of these options, or as many of them as we want, in the spatial pipeline flags. So let's go ahead and do that now. Now you'll notice we get an error because we need to have this spatial pipeline successfully exist or successfully be created. So I'm going to go ahead and force unwrap it, but hold your horses because something tells me we need some reverb nodes in our graph. So just as everything else, let's see how we would go about adding reverb nodes. I don't see a reverb node anywhere in here. So I wonder what we're supposed to do. So first, I'm going to go ahead and go to the WWDC website, which I'll link in the description below with the demo. So supposedly, we need to add another node, which is the sampler node, and that will actually play the sound back, similar to the AU sampler, if not the same thing. Not sure how all of this works under the hood, but it's very, very similar to things we've done in the past. And we give that sampler node our mixer definition, set the calibration mode to relative SPL, because in the real world, we use SPL to measure loudness. And also we want to set up a sound event. So we create that sound event, and after that, we start the engine. So supposedly all this should work. I'm going to force unwrap because I know we'll just get an error in the console if things don't work, but ideally you would want to handle those errors. All right, was it that easy? Let's find out. Well, first we also want to change this drum event to drum loop because I think that's what we're supposed to do. Okay, so now that we got this class set up, let's go ahead and create a state object. This means that this content view will create this audio spatializer whenever the view is loaded. And since it's a state object, if a published variable changes within the audio spatializer class, it will let the view know to update. But in this case, we don't have any published variables, so we don't need to worry about that. So let's go ahead and create that state object, and we'll call it audio spatializer. And as soon as we initialize this object, then the audio will start, or should start, if everything's working. Okay, cool. So now that's created, let's go ahead and see what it sounds like. Make sure the console is visible so we can see any errors. Wah, wah, wah. Looks like we got an error. So why is this error happening? This is what goes on in my brain when I'm learning these things, and I wanted to show you guys this. Oh, okay, maybe we need to scroll up and see if there's another error. Ah, there we go. Sound asset error, unsupported channel layout. Okay, looks like we can't use stereo headphones for some reason. So let's go ahead and use just plain old stereo for our channel layout. So we'll do K audio channel layout and stereo. All right, let's try again. Will it work? No. So it looks like we have sound event node asset not registered. Oops, we forgot to create or actually register the sound event. And that makes sense why we need to give this sound event a name as well. So I'll go back to the WWDC website and copy and paste this code right here. This connects our sampler node to this event, so it will tell the sampler node to trigger that event when something happens, or when we want it to be triggered. So let's go ahead and create that sound event, name it drum event, and we go back up and replace drum loop with drum event, right? Oh, first we'll force try that because we'll just get an error in the console. Ideally, again, you want to handle that though. Okay, that looks all good. So now we've registered our sound event, and I'm going to change this to drum event. I knew I was doing something wrong. Okay, let's try again. Will it work? And no. Let's see, so we have missing required spatial ambient mixer parameters. When in doubt, copy the Apple code. When in doubt, copy the Apple code. Let's see what they did. Well, it looks like we have a bunch of options here that we'll play with later. We have the listener, which we did not set up. That would be important. Let's go ahead and copy that. And then we also have the source, which again, we did not set up. The source would be like your speaker in the environment, but we didn't set that up yet. So let's go ahead and do that. So I set the listener, and of course I need to force try everything. Don't recommend doing that, but we're gonna do it here to save time. And then I'm going to create the volumetric source. This is some kind of funny shape, forgot the name. Oh, it's an icosahedron. Put icosahedron in the images, I guess. I don't know what that looks like in my head because I don't know enough geometry, but that's what we're gonna add. Now, the one thing I'm still stuck on is how do we add the parameters here? Well, first I'm gonna force try both of those, and then I'm going to see if there's a way we can initialize this. When in doubt, copy the Apple code. Let's see what they got. Oh, it looks like they already have it here. So we have the mixer parameters, and first they initialize the phase mixer. Ha, I knew it. It was not static. We need to initialize it first, and then we add the parameters. Well, good thing we have the source and the listener. So all we need to do is pass those in, and it should work. Aha, so we pass in the spatial mixer, but that doesn't exist because that's not our code. We named it mixer. And then we force try this. Again, this has to be the millionth force try. Let's try it and see if it works now. Uh-oh, source transform. Oh, it looks like we need to initialize this SIMD vector. Bunch of math. Haha, linear algebra brings me back. Let's go ahead and initialize that. Okay, error's gone. Will it work? Hey, look at that. We got music. I am happy. Hey. All right, we are almost there, but you noticed something strange about that, did you? Well, it didn't really sound spatial to me, and I looked in the console, and it looks like we have some warnings here. First warning is Spatializer Manager.mm line 110 XTCHRIR doesn't exist for this device, falling back to default. So my guess is, since I'm running this on a Mac, maybe it doesn't have some kind of impulse response that it needs, but we'll ignore that for now. The main issue that I'm seeing is that all of these reverbs don't have the associated metadata that they need. So what I'm going to do is close out of that icosahedron. I still don't know what that shape is, and I'm going to copy the reverb definition. I believe they did make a reverb up here. Yes, here it is. So we have spatial pipeline options, and then we initialize the spatial pipeline, and then we have the entries here. So it looks like they're accessing those entries and then setting the levels and the room. So we set it to medium room. So I'm going to go ahead and do that and see if that resolves some reverb issues that we were having. So I'm going to copy those two lines, and I'm going to insert them right after we define our spatial pipeline. And you know what? Let's get rid of these early reflections for now. I'm just going to do that. Late reverb, and then we'll set the send level for that to 1. And this is going to be our spatial pipeline. So we need to define that as its own constant. So I'm going to say let pipeline equal, and then paste, and then we're going to do pipeline here. And now we should get that. And then we'll do pipeline as well in the initialization. And aha, looks like we got something. All right. Let's try it out. Hey, sounds like we got some reverb. And we saw here in the console that all of those other warnings, ignore this first warning, by the way. That was something I tried to do a while ago with Unreal Engine, but ignore that. We saw that the reverb warnings went away, so that's good. We still have this device-specific warning that I'm not too sure about, but it looks like we succeeded in spatializing some stuff. And that's unfortunately all the time I have for this episode, but in summary, today we learned a little bit about the phase framework. The first half of the video was rather trivial in explaining everything this framework has to offer, but the second part, you got to see a little bit of my learning side of things and how I go about learning these crazy frameworks. But it was really cool to see in the end that we can use transforms using matrices and some maths, and we could also use reverb to make the mixer mix the audio as an environment, which I think is super cool. Another thing we saw is that we actually possibly aren't using the regular audio units under the hood, but we saw some reverb IR responses that came up in the warnings, which I found fascinating. But if you enjoyed this video, I hope you did. Make sure to leave a like, leave any feedback or ideas you have in the comments down below. Make sure to subscribe, support the channel, really helps me grow, and turn on those notifications if you want to see when I upload a new video. And I will end it off and send you guys off. Hope you have a good week. I will see you next time. Peace.